We are aware that translation moves an object from one position to another. Now, this object here can be a point, it can also be a line. So we'll deal with a point and a line. So let's begin with a point. So imagine we have a point of, let's say, 0 and 1. So in the point of 0 and 1, if we draw the graph of that, so we will have it located around there, 0 and 1. Now we want to translate this point now such that it will move 5 units on the x-axis and 6 units on the y-axis. And the y, 6 units. So all we just have to do is to add 5 units on the x, 6 units on the y. Now we can see how easy it is. So this brings us back to matrix addition and subtraction. Notice that they must be of the same order. So this is a 1 by 2 matrix, and likewise this is a 1 by 2 matrix, and the result is gotten by the addition of their corresponding terms. So this will be 0 plus 5, and we will have 1 plus 6. So the resulting point now will be 5, 7. So if we come here now, let's say this is 5, and let's say this is 7. So it will be around here, 5, 7. This is the new point. So what then do we now tag as translation? Now we know that it's 3D transformation. The translation has its own vector, the scaling has its own form of vector, and likewise the rotation has its own rotation vector. So let's call this translation on the x, and let's call this translation on the y. So the translational matrix is given as tx, ty. This is for 2-dimensional, and for 3-dimension it will be tx, translation on the x, translation on the y, and translation on the z-axis. So this will be the 3-dimensional. So this is called the translation matrix. Now let's take another example. Let's say I want to translate a point again. Let's say 2, 3. I want to translate it using 2 units on the x, and likewise 2 units, or let's say 3 units on y. So all I just have to do is say that since it's 2 units on the x, I know that my tx as translation on the x is 2, and likewise my ty translation on the y is 3. Then I will now add 2 and 3 to it. So the resulting will be what? 2 plus 2, since they are both matrix, 1 by 1 matrix, and 3 plus 3. So this will be equal to 4, 6. So if you draw a graph, or representing these things, so let's say we have 2, 3 here. Now when it is being translated 2 units on the x-axis and 3 units on the y-axis, we will have our new point here, say 4, 6. So this point has been moved to this point. Now let's now move a line. Moving a line, it's quite interesting, all right? So let's say I have a line 1, 2, 3, 4. Remember, this represents a point, 1, 2 represents a point, 2, 4 represents another point. So when it is being combined together, it results into a line. So if you draw the resulting graph for that now, let's say I have the graph here. Okay, so this is y, this will be x. Now I have 1, 2 here as a point, and likewise I have 3, 4 here as another point, Now this forms a line. Now I want to translate it with 2 units on the x-axis and 3 units on the y-axis. 2 units on x, 3 units on y. So therefore I'm saying that my translational vector of tx is 2 and translational vector on y is 3. So all my x will be 2 and all my y will be 3. So this will be the resulting. Now if you look at it now, it's a line 2 by 2. The translational vector matrix is also 2 by 2. So the resulting therefore will be 3, 5, 3, 5, 5 and 7. So therefore I can go back now and draw my translational vector, or sorry, my translated vector rather, and this will be 3, 5. Let's say 3, 5 is here, 3, 5, and likewise I will have 5, 7 here. So this object has been moved to become this object. It was moved by 2 units on the x-axis and 3 units on the y-axis. It's not totally perfect, but I trust to get the logic behind it. So now we have done for 2-dimensional matrix objects. Now let's look at 3-dimensional objects. Let's say we have 0, 1, 1. So this is a 3-dimensional vector. We have the x-axis, we have the y-axis, and we have the z-axis. And we want now to translate it according using, okay, let's say I have 2 units on the x, 1 unit on y, and 3 units on the z-axis. So I'm saying in essence that my translational value for x is 2, and my translational value for y is 1, and for z is 3. So I can have it to be 2, 1, 3, and I'm going to add it to the vector given 0, 1, 1. And therefore the new point, now remember when we have just a single line is a point, the new points therefore will be what? 2, 2 and 4.